Hello everyone, this is Muhammad Rija. In this session, I'm going to explain about basics of wireless network technology. These are the content I have planned to cover. What is protocol? What are the importance of standards? Function of few standard bodies which are very useful for wireless communication, relationship between IEEE and ETSI, IEEE standards related to wireless communication, layers and function of ISO 7 layers, function of TCP/IP protocol suite, relationship between ISO OSI 7 layers and TCP/IP protocol suite, analog signal, digital signal, amplitude, frequency, phase of sinusoidal signals. How do you find out the bandwidth of a signal? Explain the impairments, noise, distortion, attenuation of a transmission media, latency of a signal, modulation, multiplexing, FDMA, TDMA, and OFDM, data word and code word, how the errors can be detected from block coding, how the errors can be corrected in block coding, cycle code and checksum, importance of flow control, HTLC protocol, HTLC frame via lane need an additional layer like MAC layer, function of MAC layer, function of LLC layer, IEEE 802.11 architecture. Now we'll see what is protocol. A network protocol is an established set of rules that determine how data is transmitted between different devices in the same network, which means it allows the connected devices to communicate with each other regardless if any differences in their internal processes, structure, or design. Network protocols are the reason you can easily communicate with people all over the world and thus play a crucial role in modern digital communication, which means it is a standard. Protocol means it is a standard, right? Now we'll see what are the importance of standard. Standards describe accurately and ambiguously how information is transmitted. A manufacturer products will work successfully with other manufacturer products if they all follow the same standards. By defining a set of standards, you are providing a framework within which all manufacturers can design new or successful products. Standard break down complex ideas into smaller, methodological, or easier to understand components. Example, there are few standards available for the wireless network: IEEE 802.11, Wi-Fi, and HyperLAN, right? Now we'll see function of few standard bodies which are very useful for wireless communication. The wireless networking equipment available support varying levels of industry communication standards. At present, the IEEE 802.11 standard is widely accepted throughout the industry and provide the necessary balance of range, network through output, and support of device mobility to effectively serve the most needs of the university community. As newer standards emerge, such as IEEE 802.11 enhancement, they will be evaluated and deployed should they offer security and throughout the improvements over 802.11. Two standard bodies are primarily responsible for implementing WLAN, IEEE and the Wi-Fi Alliance. IEEE defines the mechanical process of how the VLAN, WLAN are implemented in the 802.1 standard so the vendors can be create compatible product. The Wi-Fi Alliance mean basically certify the companies by ensuring that their product follow the 802.11 standard, thus allowing customers to buy WLAN product from different vendors without having to be concerned about any compatible issues. Now we'll see relationship between IEEE and ETSI. IEEE is a large global technical professional organization is dedicated to advancing technology for the benefit of humanity. IEEE is the trusted voice on a wide variety of areas ranging from aerospace system, computers and telecommunication to biomedical engineering, electric power and consumer electronics. ETSI produce globally applicable standards for information and communication technologies, which mean ICT, including mobile radio coverage, aeronautical broadcast, and internet technologies, and is officially recognized by the European Union as a European Standard Organization. These are the standards related to wireless communication. As you can see, IEEE standard, there are several standards released in several years. In 1999, they released 802.11a in its frequencies for 5 gigahertz. Maximum data rate is 54 megabytes per second. After that, in 1919, later 1919, 802.11b, they released and the frequency is 2.4 gigahertz. The maximum data rate 11 megabyte per second. In 2003 they have released 802.11g, 2009 802.11n, 2014 802.11ac. Recently they have released 2019 they have released 802.11ax. The maximum data rate is 11 to 12 GB. Frequency is 2.4 gigahertz and 5 gigahertz. Now we'll see layers and function of ISO OSI 7 layers. There are 7 layers in ISO OSI layers. First one is physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Physical layer mean physical equipment, which mean cables, those are under the physical layer. And data link layer mean define the format of data to the network. Network layer decide which physical path the data will take. Transport layer transmit data using transmission protocol including TCP and UDP. Session layer maintain the connection between two computers. Presentation layer ensure that the data is usable format and it is where data encryption occurs. Application mean human computer interaction layer where the application can be accessed the network services, which mean if we want to see an email, our application server layer is a Google Chrome. Without Google Chrome or the platform, we can't see our email. These are the protocol which use in every layer, 7 layer, physical layer, wires, those are data link layer, frames, Ethernet, PP switch, bridges, those are under the data link layer. Network packets, IP, ICMP, IPsec, IGMP, those are network. Transport layer, end-to-end communication connection, TCP, UDP. In session layer, there are API socket, WinChalk. Presentation, those protocols, SSL, SSH, IMP, FTP, MPG, JPG. In application, it's TP, FTP, IRC, SSH, and DNS. These are the function of TCP/IP protocols. TCP/IP protocol. In TCP/IP protocol, there are 4 layers: network interface, internet, transport application. Application layer to allow access to the network resources. Transport means to provide reliable process to process message delivery and error delivery. Internet to move packet from source to destination, provide interworking. Network interface is responsible for transmission for the between two devices on the same network. These are the protocols used in TCP/IP protocol, data link, Ethernet, ARP, networking, IP, ICMP, transport layer. We are using TCP, UDP, application layer. We are using HTTP, FTP, POP3, SMTP, SNP. These are the relationship in OSI and TCP/IP. In OSI, there are 7 layers, but TCP, we have only 4 layers. Now we'll see relationship between ISO 7 layers and the TCP/IP protocol. We don't want to see the all. I'll explain few of things. OSI is a generic protocol independent standard acting as a communication gateway between the network and the user. TCP/IP model based standard protocol around which the internet has developed. It is a communication protocol which allows connection host over a network. In OSI models, the transport layer guarantees the delivery of packet. TCP/IP model, the transport layer does not guarantee delivery the packet. Still, the TCP/IP model is more reliable. Follow vertical approach. OSI follow the vertical approach. Follow horizontal approach. TCP/IP follows horizontal approach. Right? There are I have given. You can go through it. Now we'll see what is analog signal. Analog signal is time varying and generally bound to a range, especially plus 20 volt voltage to minus 20 volt, but there is an infinite number of values within that continuous range. Analog signal use a given property of the medium to convey the signal information such as electricity moving through the wire. In an electrical signal, the voltage, current, or frequency of the signal may be varied to represent the information. Now we'll see digital signal. Digital signal is a signal that is used to represent data as sequence of separate values at any point in time. It can only take fixed number, vary either one or zero. Right? It's take only 0 and 1. Now we'll see amplitude, frequency, and phase of sinusoidal signals. Right? Sinusoidal signals are smoothly varying. There are no abrupt changes in amplitude, which means a flat. The rate at which the amplitude changes, we call this the slope. It's not constant. In fact, the slope of a sinusoid varies the sinusoidal fashion. Sinusoidal signals occur in repeating cycles. The number of cycles that occur in 1 second is equal to the frequency of the signal in hertz. Real-life sinusoidal signals have amplitude that vary with respect to time. However, we can also describe the horizontal progression of the signal using degree. The completion of a null full cycle corresponds to an angle that varies from 0 to 360 degree, and the halfway point of the cycle occurs at 180 degree. How do you find out the bandwidth of a signal? Now we'll see how do we find out bandwidth of a signal. The bandwidth of a signal defined as the difference between upper and lower frequency. Here upper frequency, here you can see lower frequency. The differences between upper and lower, we call it bandwidth of a signal. Explain the impairments, noise, distortion, and attenuation of a transmission media. Attenuation means a loss of energy. The strength of a signal falls off with distance over any transmission medium. Distortion means that the signal changes its form or shape. The distortion is caused by the fact that the velocity of propagation of a signal through a guided medium varies with frequency. Noise refers to any unwanted signal. For any data transmission event, the received signal will consist of transmitted signal modified by the various distortion imposed by the transmission system, plus additional unwanted signal that are inserted somewhere between transmission and reception. Now we'll see latency of a signal. In terms of network latency, this can be defined by the time it takes for a request to travel from the sender to the receiver and for the receiver to process that request. In other words, we can call it the round trip time from the browser to the server. It obviously desired for this time to remain as close to zero as possible. However, there can be a few things at play preventing your website latency times to remain low. Now we'll see modulation. Modulation is the process of converting data into radio waves by adding information to an electronic optical carrier signal. Carrier signal is one of the steady wave constant height or amplitude and frequency. Here our message signal and modulation mean it add carrier signal. After that we are getting modulated signal. There are two type modulation, analog modulation and digital modulation. Analog there are method amplitude modulation, frequency modulation, phase modulation. In digital modulation, we have three: amplitude shift keying, frequency shift keying, phase shift keying. Multiplexing. Now we'll see multiplexing. Multiplexing is a technique used to combine and send the multiple data stream over single medium. The process of combining the data streams is known as a multiplexing, and hardware used to multiplexing is known as a multiplexer. We are using multiplexer to do the multiplexing. Now we'll see frequency division multiplexing, FDM. We are using for analog technique. Frequency division multiplexing is a technique in which the available bandwidth of a signal transmission medium is subdivided into several channels. Now we are calling as FDM. TDM is used for digital technique. In frequency division multiplexing technique, all signals operate at the same time with different frequency, but TDM technique, all signals operate at the same frequency with different time, right? Now we'll see FDMA, TDMA and OFDMA. FDMA is the process of dividing one channel or bandwidth into multiple individual band each for use by a single user. TDM is a digital technique that divides a single channel band into time slot. Each time slot is used to transmit one byte or another digital segment of each signal in sequential serial data format. OFDMA is a technique used for LTE network, long-term evaluation, cellular systems to accommodate multiple users in a given bandwidth. Orthogonal frequency division multiplexing is a modulation method that divides the channels into multiple narrow orthogonal bands that are spaced so they don't interfere with another. Now we'll see data word and code word. Data can be corrupted during transmission. When we transfer the data might corrupted. Some applications require that errors can be detected and corrected. Errors be detected and corrected. There should be a correction and detection. There are three types of errors: single bit error, multi bit error, burst error. To detect and correct errors, we need to send extra redundant bit with the data. To correct the errors, we have to send redundant bit with data. Those methods we call it data word and code word. Now we'll see data word and data word in block coding. In block coding, we divide our message into block. Here we are dividing our message into blocks, each of k bits, called data word. Here these are called data word. In block coding method, we are dividing the message into blocks. Here these are our block. We call it data word. After that, Code word. Code word mean we add R redundant bit to each block to make the length n plus k plus r. The resulting n bit blocks are called code word. Here, our message convert into data bit. After that, we add one redundant bit and get the code word. In that code word, send it to receiver, and receiver check whether it's a original or fake message. How the errors can be detected from block coding. If the following two conditions are met, the receiver can detect a change in the original code word. The receiver has or can find a list of valid code words. Second one, the original code has changed into invalid one. If the received code word is not valid, it is discarded. However, if code word is corrupted during the transmission, but the received word still matched a valid code word, the error remains undetected. The, this type of coding can detect only single errors or two more errors may remain undetected. How the errors can be corrected in block coding. Error correction is much more difficult than error detection. In error detection, the receiver need to know only that the received code word is invalid. The error correction, the receiver need to find or guess the original code word sent. So we need more redundant bit for error correction than for error detection. Now we'll see cycle code and checksum. Cycle code also one of the method to check the validate the message. Cycle codes are special linear block codes with one extra property. In a cycle code, if code word is cycle is shifted, they are shifting the code. The result is another code word. For example, if 10110000 is our message, is a code word, and we cycle it, we are shifting the code word. It is also code word. We are shifting. We are shifting mean second shifting mean here there are 1 2 3 4 5 6 7 ones in zero. Second, first one replaced with second. Here, second one replaced with here. First one is replaced here as second. Likewise, we are replacing. The checksum is used in the internet by several protocols, although not at the data link layer. Like linear and cycle code, the checksum is based on the concept of redundancy. Several protocols still use the checksum for error detection. Transmit buffer and receive buffer. The binary codes are generated by the transform coder from the input to a transmission buffer. The function of the transmission buffer is to keep output rate of the encoder fixed. The receive buffer mean it allocates a receiving buffer from the specified connection. Most implementation return immediately from the receive code, even if the data has not been received. Now we'll see importance of flow control. It is an important function of the data link layer. It refers to a set of procedure that tells the sender how much data it can be transmit before waiting for acknowledgement from the receiver. Any receiving device has a limited speed at which it can process incoming data, also limited amount of memory to store incoming data. Now we'll see HGLC protocol. HCL means High Level Data Link Control is a group of communication protocols of the data link layer for transmitting data between network points or nodes. Since it is a data link protocol, data is organized into frame. A frame is transmitted via the network to the destination that verifies its successful arrival. It is a bit-oriented protocol that is applicable for both point-to-point multiple communication. NRM means two types of station. There are primary station that send command and we respond to receive command. It is used for both point to point and multi-point communication. Here we have only one point, so this is called point to point communication. Here we have two stations, so we call it multiple point. Here we send the command and the station get the response. Another method is asynchronous balance mode (ABM). Here the configuration is balanced. Each station can be both send command and respond. Both both station it can send command or it can do both command or response. Now we'll see HDLC frame. HDLC is a bit-oriented protocol where each frame contains up to 6 feet. The structure varies according to the type of frame. The field of HDLC frame are here first byte is flag, second byte flag mean it is an 8-bit sequence that mark beginning and end of the frame. The bit pattern of the flag is 01111110. Second is address control payload FCS and flag. Why the LAN need an additional layer like MAC? The data link layer we have two sublayer. First one is a MAC sublayer. Second one is a logical link layer. The MAC sublayer control device interaction. The LLC sublayer deals with the addressing and multiplexing. These are the function of MAC layer. It provides an abstraction of the physical layer to the LLC and upper layers of the OSI network. It is responsible for encapsulating frames so that they are suitable for transmission via the physical medium. It resolves the addressing of source station as well as the destination station or groups of destination station. It generates the frame check sequences and thus contribute to protection against transmission errors. These are the function of LLC layer. The primary function of LLC is to multiplex protocol over the MAC layers while transmitting and likewise to demultiplex the protocols while receiving. LLC provide hop-to-hop flow and error control. It allows multiple communication over the computer network. Frame sequence numbers are assigned by LLC. In case of acknowledged services, it track acknowledgement. Now we'll see these are IEEE 8.0 architecture. IEEE 802.11 standard, popularly known as a Wi-Fi laydown architecture and specification of wireless LAN, Wi-Fi or wireless LAN, use high frequency radio waves instead of cables for connecting the device instead of cable we are using wireless LAN. User connected by WLAN. Wireless LAN can move around within the area network. That's it. Thank you for hearing my presentation. Thank you very much.